Welcome to our exploration of a pressing topic in sustainability, the truth about electric vehicles and their environmental impact. While many hail EVs as the solution to our climate crisis, the reality is more complex than it seems. In this video, we will delve into key issues such as battery production emissions, the importance of electricity sources, and the challenges of recycling. Join us as we uncover the hidden truths behind electric cars and their true role in tackling emissions. Battery production emissions. Electric vehicles, or EVs, have been hailed as a solution to the pressing issue of vehicular emissions. However, the production of their batteries tells a different story. The manufacturing process, particularly for lithium-ion batteries, is incredibly energy-intensive. This results in significant carbon emissions, often surpassing those from the production of internal combustion engine (IC) vehicles. The extraction and processing of raw materials like lithium, cobalt, and nickel require substantial energy, typically derived from fossil fuels. As a result, the environmental cost of producing an EV battery can be surprisingly high. It is a paradox where a vehicle meant to reduce emissions starts its journey with a hefty carbon footprint. This initial environmental debt is a critical consideration when evaluating the true greenness of electric cars. Electricity source matters. The emissions associated with EVs are not solely confined to their production phase. The source of electricity used to charge these vehicles plays a pivotal role in determining their environmental impact. In regions where electricity is predominantly generated from fossil fuels, such as coal or natural gas, EVs indirectly produce more emissions. This means that while the vehicle itself might not emit harmful gases, the power plants supplying its energy might. The contrast becomes apparent when comparing areas with renewable energy sources where EVs can genuinely reduce emissions. Thus, the advantages of EVs are closely tied to the energy mix of the local grid. The greener the grid, the greener the EV. Understanding this connection is essential for comprehensively assessing the environmental benefits of electric vehicles. Energy efficiency. Despite the challenges posed by battery production and electricity sourcing, EVs have a significant advantage: energy efficiency. Compared to ICE vehicles, EVs convert a higher percentage of the energy from their fuel source into actual movement. This means that even when charged from fossil fuel-heavy grids, they often generate fewer emissions over their lifetime. The efficiency of electric motors, which have fewer moving parts, contributes to this benefit. For instance, while an ICE vehicle might use only 20% of its fuel energy for propulsion, an EV can use up to 80%. This efficiency plays a crucial role in offsetting the emissions produced during the battery manufacturing process. In essence, the longer an EV is in use, the more it can capitalize on its efficiency edge over traditional vehicles. Or mining impacts. The materials required for EV batteries, such as lithium, cobalt, and nickel, are extracted through mining processes that pose environmental and ethical challenges. Mining can lead to land degradation, water pollution, and loss of biodiversity in affected areas. Moreover, the mining industry is often criticized for poor labor practices, including hazardous working conditions and child labor. The demand for these materials has surged with the rise of EVs, intensifying the pressure on mining operations worldwide. This situation creates a complex ethical dilemma for consumers and manufacturers alike. While the shift to electric vehicles aims to reduce emissions, it is important to address the impacts of mining to ensure that the entire supply chain is sustainable and responsible. Balancing these conflicting interests is crucial in the pursuit of a truly green transportation future. Life cycle emissions. To fully understand the environmental impact of EVs, it is vital to consider their life cycle emissions. This encompasses emissions from manufacturing, operation, and disposal. Over their entire life cycle, EVs typically produce fewer greenhouse gas emissions than ICE vehicles. This advantage becomes more pronounced as electricity grids transition to renewable energy sources. The initial carbon footprint from battery production can be mitigated by the vehicle's efficiency and the potential for cleaner energy during its operational phase. However, achieving this requires a collective effort to shift towards sustainable energy sources and improve battery production methods. The life cycle perspective underscores the importance of long-term planning and investment in renewable energy to maximize the benefits of electric vehicles. Recycling challenges. As the number of electric vehicles on the road continues to grow, so does the challenge of battery recycling. While technologies for recycling EV batteries are improving, a significant portion of used batteries still goes unrecycled. This raises questions about waste management and the sustainability of the EV industry. Efficient recycling processes are essential to recover valuable materials and reduce the need for new mining operations. However, the development and implementation of such processes are still in progress. The ability to recycle batteries effectively will play a crucial role in minimizing the environmental impact of EVs and ensuring their long-term viability as a green transportation solution. Comparative air pollution. One of the most significant advantages of EVs is the elimination of tailpipe emissions. This reduction in local air pollution is particularly beneficial in urban areas with dense populations. Cleaner air contributes to improved public health and a better quality of life. However, it is essential to note that tire and brake particulate pollution remains an issue for all vehicle types, including EVs. These particulates can contribute to air pollution and pose health risks. While EVs offer a cleaner alternative to ICE vehicles, addressing these non-tailpipe emissions is crucial for achieving comprehensive air quality improvements. A holistic approach to reducing vehicular emissions is necessary to realize the full potential of electric vehicles in urban environments. Future potential. The environmental impact of EVs is poised to decrease as renewable energy sources become more prevalent and battery technologies improve. The ongoing advancements in recycling processes also hold promise for reducing the industry's environmental footprint. As grids transition to cleaner energy and battery production becomes more efficient, the benefits of EVs will become increasingly pronounced. The potential for electric vehicles to contribute to a sustainable future is significant. However, realizing this potential requires continued investment in renewable energy infrastructure and responsible supply chain practices. By addressing the challenges and opportunities presented by EVs, we can work towards a greener and more sustainable transportation landscape.